Hello, everyone. My name is Dan Lewin. I'm the CEO of the Computer History Museum. I'm very pleased to welcome you all here today for this update and presentation. I wanted to start by just introducing myself and setting up some context for this program. I've been in the computer business for over 40 years. I was at the opening of the Computer Museum in Boston in 1979 in the very beginning of the display of the collection, which is now housed by the Computer History Museum. When you go back that far and you start to think a little bit about where museums were at that moment in time and the use of technology and automation, you can see we've come a long way. At this stage, when I was asked by the trustees if I'd be interested in running this museum about 3.5, almost 4 years ago, the first question I had was, well, I don't know that much about museums, but I'd always been a fan of museums. I'd run all my professional and business programs in museums. Cultural institutions are fundamental to my core, but I didn't know a lot about the infrastructure or operations. When I started, the first concept I laid out, well, there were 3 things we needed to do at the Computer History Museum. One was to reposition the institution to focus on the implications of computing on the human condition, because it's not about the computers anymore. They're everywhere. Life as we know it doesn't exist without computing. The second thing was to envision what the institution would look like 10 years from now, which was nearly 3.5 years ago. And that was a technology statement. And the good news is that I found Dave Evans, who you'll hear from soon, who's our CTO. And we already had Paula Jablonner, who is the curator in charge of our collections. So the question we posed is, if not the Computer History Museum, who? And so we've embarked upon a process to begin the automation of the infrastructure for all museums over the course of this 21st century. So what you're going to hear today is the beginning and the first stages of what I will consider a glass that is more than half full. This technology is going to move at an incredible pace, and it is going to augment the human capabilities that are essential to the organization and operation of museums. But mark these words, I've been in this business for over 40 years, part of the team that built the original Macintosh. I've been tracking technology for over 40 years. It's coming, and it's coming fast. So enjoy the presentation today. You'll hear from Dave first, and he'll move on thereafter. So again, thanks for joining us today, and we'll welcome your context and communications.
Thank you, Daniel, and welcome everyone. And we're pleased you can join today so we can talk about our journey we call Openchm. And a stepping stone on that journey is our experience and learnings with machine learning. So over the course of the next hour, my colleague and I, Paula, and I will talk about our experience and learnings with cognitive services and machine learning against a subset of our collection. So with that, I would be remiss if I did not begin with some acknowledgement and some thank you for some organizations that allowed us to make this happen. So about a year or so back, we received a grant from the Institute of Museum and Library Services, or IMLS. So a huge thank you to them for helping to make this possible. In addition to them, we also received some assistance from the Gordon and Betty Moore Foundation, who are great partners and great friends of the museum, and a huge thank you there for them, to them for their contribution also. And then finally, I'd be remiss if I did not also mention Microsoft. Microsoft has been an amazing corporate partner to the Computer History Museum, and the technology and the demonstration we'll show you later on in this presentation would not have been possible without their technology framework and their cognitive services or machine learning framework. So a huge thank you to our partners and supporters that made this happen. Now, over the course of the next hour, we have a very rich agenda. So very quickly, this is what we're going to cover. So we'll start with about the Computer History Museum. Who are we? Where do we come from? What are we doing? And a little bit of background about why we embarked on this. Why do we look at machine learning at all, or artificial intelligence as it relates to the collection? So we'll touch on that. We'll talk about specifically what we did, the approach that we took, and why we selected some of the items that we did. And then we'll talk a little bit about the technology we used to make this happen. We'll then go into a demonstration, sort of bring this thing to life, and sort of show you the prototype that we built. And then we'll talk about some of the results and the learnings, and what do we learn from this, and what worked and what didn't work. And then we'll talk about next steps. And as I mentioned, this is just sort of a stepping stone, a much broader initiative we call OpenCHM, which is sort of a technology and a philosophy about opening up the museum and opening up the collection. So we'll talk more about that a little bit. And then as time allows, we'll open up for Q&A. So with that, let me turn it over to my colleague, Paula, to talk about the museum and who we are.
Thank you, Dave. So the museum has been in Silicon Valley since the mid-1990s. We're located in Mountain View, and we believe in inclusion, diversity, equity, and access are fundamental to creating and harnessing technology to serve humanity. We have multiple programs, and I'll just give you a brief overview. We really try to tell things through stories. I know this webinar won't be quite a story, but in a way it will. We have education, we have live programming that's gone virtual in the last 2 years. We have 2 exhibits, 2 permanent exhibits and a rotating gallery. The main exhibit is Revolution, the first 2,000 years of computing, which will be finally open again tomorrow, and make software change the world. And we also just try to get our content out there as much as possible. And I'll talk about the collection in the next slide, but this whole grant and this whole endeavor is really about getting our content out there. And that's what's really the most exciting thing about the museum, is that we have all this stuff, but we've never been able to make it accessible and out there in all kinds of forms, not just traditional research forms. And we also have a large cadre of volunteers that are wonderful to work with and really integral to the museum. And a lot of them are come right from Silicon Valley. Next slide, please. So the museum was actually the brainchild of Gordon Bell, and it came out of work of a number of people who worked at Digital Equipment Corporation in Massachusetts in the 1970s. And it's really, they saw a lot of their heritage disappearing, and they started collecting stuff before it went away. So the first items that were ever exhibited that are still in our collection were in DEC's main lobby, and then the collection actually moved to downtown Boston, and there was a number of really well-received exhibits there through the mid-90s. By the later part of the 90s, it was clear that the museum wasn't doing as well. And the whole collection actually came out here to Silicon Valley. And it was originally at Moffett Field, for those who might know Moffett Field. And then we moved into our current building in 2002, and we opened our first permanent exhibit in 2011, Revolution. Next slide, please. So the collection is really the heart of the museum. In the Boston years, the collection was almost exclusively on physical objects, but it really expanded once we moved to Silicon Valley. And it became just as important to be a research institution and have a much broader content base at that point. So over the last 25 plus years, we've collected a lot more than physical objects. We most likely have certainly the oldest and broadest software collection anywhere, and that's very unique. Our earliest software dates from the 1950s, from MIT's Whirlwind computer. But also in the Silicon Valley, we started doing our first archival collections, and we have 11,000 feet of archival material. And I think for purposes of the webinar, moving images and oral histories are really the key of what we're talking about. Not to say that the other collections aren't important, but we were experimenting with moving images, and moving images to anybody who works at a museum or archive has always been this black box. And I'm really excited about the way that we can make these accessible once you digitize them. And I'll talk more about that later. So now I'm going to hand it over to Dave to give you background on the grants.
Thank you, Paula. Now, as you heard, we have a pretty significant collection, and it's only growing. A large percentage of that collection is oral histories. We have about 1,000 oral histories, which are essentially videos where we sit someone down in front of a camera, technology expert, pundit, someone that's made a significant contribution to the computing space or industry, and essentially record their life story. And we record that in video form. And as you can imagine, some of these videos are quite lengthy, 6 to 8 hours long. And to sit down in its entirety and watch a video is very time consuming. But what if we could use technology to take that content and mine it, to look at the content within it in a different way? If we could recognize faces and objects and do language translation so we could expose it to a broader audience. And what if we could take that content and relate it to other things in the collection to tell different types of stories and make connections that perhaps we couldn't find before? So that was really the promise of machine learning. So as you've heard, we've got a very large, diverse collection. And a large percentage of the people that visit the museum, whether online or in person, are not necessarily native English speakers, and yet much of the collection is in English. So machine learning and artificial intelligence holds a great promise to translate content into other languages and to be able to present our content to other individuals on their terms. And as I mentioned, being able to mine the collection, not just for the curatorial staff, but also for the folks that are interested in searching the collection themselves. So a lot of promise for machine learning. We're a very innovative organization, and as Daniel said, if not the Computer History Museum, then who? And as I mentioned in the onset, a huge thanks to IMLS and Gordon Moore and Microsoft to help make this happen. So multiple reasons why we did this. Now, what we did is we sort of followed a fairly traditional waterfall model in terms of our project plan, looked at the requirements and sort of gathered the requirements and built some early wireframes to think about how do we want to build this? How do we want to sort of design this this prototype? So we built a very sort of rough prototype we'll show you in a moment. And it really was about testing the efficacy of machine learning against a subset of the collection. The collection is massive, about 170 terabytes of content. We picked a very small amount of that collection to test, about 60 videos, a few dozen images, some PDF documents, that type of thing. So a small subset that we could get our arms around and sort of test the technology. We engaged a third-party developer to help build the portal for us, and we developed the prototype. Once the prototype was developed, we then evaluated the results with both internal and external users to test. So how did we do? Is it useful, not useful? What did you like? What didn't you like? What could we do differently next time? And then we did an internal postmortem to see what could we do to improve sort of from a process perspective. And we'll share that with you in a few minutes in terms of kind of survey results and what we did. Now, in terms of the technology, I just want to spend just a moment or two talking about the technology that we used. And I never like to make the assumption that everyone understands what machine learning is all about. In the media these days and in the press, you'll hear a lot about AI and machine learning and deep learning, and often the terms are used interchangeably. So I thought it'd be just worthwhile just to take a few seconds to explain what it is and the difference between them. Just to sort of set the stage. So artificial intelligence is not a technology. Artificial intelligence is really kind of the science around machine learning. So think of AI much like biology or mathematics or what have you, or computer science. It's about studying the space, about using technology, using machines and software that can creatively solve problems. And sort of the holy grail of machine learning or AI is that it's a way to write code once that is flexible, it can work on a variety of data coming in, versus the old way of writing code where it's very algorithmic and specific to a problem set you're trying to solve. AI is a lot more flexible in terms of the algorithms and models that it uses. So AI is the broad space, that's the broad sort of science behind it. And then by the way, that's been around for decades. It's not a new technology or new space rather. But what has made it different over the coming years is really the advances in machine learning and deep learning. There's been a lot of advances in neural networks and technology in that space. So it's brought AI back to the forefront, even though it's sort of about 6 decades old. It's now sort of getting a lot of attention. So machine learning now is sort of a subset of AI, if you will. That is the technology space where we use algorithms and regression analysis and all kinds of computer science methodologies to basically analyze data. And a good example of machine learning is using spam filtering to train your email system. So it's not about neural nets yet. It's about using algorithms to sort of hone in on solving the problem. The core of machine learning is deep learning. And this is really where the magic happens. This is about trying to mimic the human brain, the human neural system. And we're not quite there yet, but we're getting closer every day. And it's about using these neural synaptic networks to train machines in much more fine-grained ways. And a great example you've seen a lot in the press lately is self-driving cars. So how do we teach a car to drive much like a human would using machine learning or machine vision to teach it to drive? So think of these as sort of concentric circles, artificial intelligence being the outer one, the science behind it, machine learning being the algorithms, and then deep learning being about kind of the emulation of the human brain. So that's sort of a big picture 101, if you will, from an AI perspective. Now, more tangibly, we use technology from Microsoft called Azure Cognitive Services or Microsoft Cognitive Services. And it's really a suite of capabilities. This is a set of capabilities that Microsoft has spent a lot of money, a lot of time building, and you can really sort of categorize it into 4 main buckets or 4 main pillars. So there's a whole rich set of capabilities. I'm not going to do it justice on this slide, but it will give you a direction of sort of where it's going, and or sort of rather a direction of what it is and some of the capabilities within it. So the first is a set of capabilities around vision. That's using machine vision to recognize faces, to recognize objects and things like that. So recognize a license plate on a car, for example, to recognize a person's face in a video, that type of thing. So there's a whole bucket of capabilities on the vision side of it. There's a whole set of capabilities on the speech side of it. So things like speech to text or text to speech. So how do you get machines to speak like the human? Or how do you recognize when someone is speaking in English or other languages for that matter? There's a whole set of capabilities around language, and that's doing things like natural language processing. So being able to understand when someone's speaking in natural language terms, but also around language translation. And we'll show you this in a moment, because this is where we spent quite a bit of time in the language translation aspect of it. I mentioned earlier that a large percentage of folks that visit the museum, both online and in person, English is not their native language. So being able to get to them on their own terms is really powerful. So being able to take all that great content we've got, 1,000 oral histories, all the documents and so on, and translate them into other languages is a very powerful capability of this technology. And then the last thing, which we didn't really do in this prototype, but just to round it out, is a set of technologies around decision making. So being able to recognize things like anomalies in a data stream or offensive content, things like that. So take a look at Microsoft Cognitive Services, a very rich set of capabilities and incredibly easy to use. API driven, you pass it an image, you pass it a video, you specify what you want to do, and then you get the results back. So a really powerful set of capabilities. So with that, let me stop talking about the technology and show you the technology instead. So I'm going to switch gears a moment now, and I'm going to switch to a browser-based demo, which is where we built a prototype, and show you sort of what we built. So just bear with me 1 second while I switch here. Okay. Now, what you should be seeing now is this is just in Google Chrome, but it can be in any browser. This is a very simple portal that we put together for the Cognitive Services prototype. And in this case, I'm going to go ahead and search for Alto. And Alto is, in this context, the Xerox Alto computer. And that was the first computer that had a graphical user interface from the inception. It was introduced in 1973, and it's really become sort of the basis for today's modern personal computing, drag and drop, WYSIWYG, mouse-based control, and so on. So I did a quick search for that, and these are the results that came back. Now, what's interesting about this is that these videos, there's about 40 odd videos here, 21 videos, about 49 items, and the search that was performed searched through all the machine-generated transcript of the video. So the transcript didn't exist. The the technology converted all the video, audio to transcripts and searched through all of that. We also had a number of PDF documents. It searched through that. And then it also searched through the machine-generated metadata of the images that were also in this small corpus of content that we had. So I'll show you a couple of these. A very sort of simple UI that we built. You can hover over content to get a thumbnail to hear it. You can filter through the content to get just the items you're interested in, images, documents, that type of thing. So I'll go ahead and select I'll start with an image to show you kind of the machine learning there. So we uploaded just a handful of images. You'll notice that in the results that came back, they're all Xerox Alto related images, whether it's a poster or someone sitting at a computer or the device itself. I'm going to go ahead and pick the second one, which is a lady sitting at a Xerox Alto, and just show you some of the metadata that was created automatically. So in this case, it analyzed the it analyzed the image and generated some automatic metadata or some image tags. And you can look through and they're pretty directionally correct. It's a person, it's a computer monitor, there's furniture involved. There's a couple of fine-tuning things. So it thinks it might be a Mac or a laptop. It's not quite that, but it's directionally correct. The one thing I will draw your attention to is the confidence score. So in this case, it says, we think that this image is a man sitting at a desk with a computer, and the confidence score is about 95, 96%. It's pretty close. It happens to be a lady sitting at a desk, but the rest is correct. And from this sort of side view, perhaps you can't tell exactly who it is, but you can see that it's a pretty good confidence score, and the rest of the information is directionally correct. So this is the automatic metadata. This doesn't necessarily replace what a human might see or observe and create in terms of metadata, but it augments that. It helps the search or the relevancy become richer. So that's kind of an example of an image. So I'm going to click back now. And the next thing I'd like to show you is a video example. And in this case, I'm going to go ahead and click on an oral history of Robert Metcalfe. So let me go ahead and click on the video. And in this video, in this particular UI, there's a few things to note. First of all, we have some drop-down menus. And the drop-down menus are certain properties or characteristics of the video that were extracted by the technology automatically about things that it found in the video. So whether it was sentiment analysis or a person or a face or a keyword, you can select from that. So the other thing that it did is it did an automatic transcription of the video. So on the right-hand side, we have the transcription of the video. And if I scroll down, for example, and click on any arbitrary piece of the video, or rather transcript, it will jump to that portion of the video.
It's much too complicated, and this has to be solved.
And the reverse is true. If I click on a portion of the video, it will jump to that portion of the transcript. So it makes it much easier to navigate the video. Instead of sitting down and watching a video in its entirety, you can search for a keyword or a face or a sentiment or something that's of interest and jump to that segment of the video. And then you can also sort of chop the video up into sizable chunks and then make relationships or correlations between them and see how they relate to other sort of videos and other things in the corpus. So a couple of things I'll show you briefly. I'm going to select the people menu. And the first thing I'll select is Andrew Grove. And one thing to note is that in the transcript that was automatically generated, it doesn't say Andrew Grove, it says Andy Grove. So the technology is smart enough to know, Andy Grove and Andrew Grove must be one and the same. It's the same thing. It also knows it's a person relative to a place or a thing or just raw text. So a lot of intelligence built into cognitive services. Now, the next thing I'll select from a people perspective is I'm going to select Gordon Bell. Now, Gordon Bell, sort of very famous person in the industry. He's an early employee of Digital Equipment Corp or DEC. He's there from 1960 to 1966. And Gordon Bell designed many of the early machines, many of the early PDP machines, and later became vice president of engineering. He was also one of the founders of the Computer History Museum, and we're very fortunate to have Gordon on the board. Now, I'm going to go ahead and select Gordon, and you'll notice that it knows that it's a person relative to, as I mentioned, just text in there. So really powerful ways to sort of search through and mine this content. And the next thing I'm going to select is under topics. This is related to Gordon. I'm going to go ahead and select the National Medal of Technology recipients. And hopefully you can see the drop down. So if I select that, you'll notice that it jumped to a section of the video that talks about Gordon Bell. But there is nothing in the transcript that talks about Gordon Bell being the National Medal of Technology recipient. He received that in 1991. The technology is smart enough to make those connections and infer that Gordon Bell was, in fact, this National Medal of Technology recipient. So some really clever sort of connections that might not be immediately obvious to a human that you can get from a machine learning perspective. And if I click on the highlighted text, of course, it'll jump to that portion of the video.
Gordon, who had been the referee on my CACM paper in '76.
I'll pause that. Now, the last feature I want to show you from a video perspective is the language translation. And I think this is one of the really interesting opportunities for our corpus of videos and so on. Like I mentioned, we've got 1,000 oral histories, and to get them out to the millions that we aspire to get out to, we need to get to them on their own terms. And English is just not going to cut it. So being able to translate from English to any other language is really powerful. Now, the Microsoft Cognitive Services supports dozens of different languages, about 36 to 40 different languages. For the prototype, we picked, I think, 7 different languages to translate from because there's sort of a CPU cost to do this. So we picked 7. And I'll show you a few examples of what that looks like. So right now you can see the transcript is in English. I'm going to go ahead and select, let's pick French, for example. And if any of you in the audience speak French, you can take a quick look and you'll find that it's pretty accurate. It's not 100%, but it's certainly greater than 95%. And it's analogous to someone, perhaps if English is not maybe their first language, but you speak to them, it's very clear what they're saying, and it's very clear to understand them. So give it a couple more years, and this is going to rival human translations. It's extremely, extremely good. So language translation is excellent. Now, if I click on the French language here as an example, it will jump to that portion of the video, but it will speak that language still in English. We did not transcribe the spoken word. That capability does not exist yet. That's coming. But in terms of overlay, you can overlay closed caption on the video in the language that you've translated to. So said a different way, you could have the transcript in French or whatever language you choose. You can have closed captions in the language that you choose, although the speaker may still speak in their native language. So I'll select just a couple of other languages to illustrate some of the breadth of this. I'll go ahead and pick Chinese, and you'll see that very quickly it translates to Chinese here. I can scroll down, and I don't speak Mandarin, but you get an idea. And then the last one I'll pick is Hindi, just to illustrate. So again, really powerful capabilities and really fast. Once it does the translation, being able to translate content into any other language from a transcript perspective is a really fast and really powerful way, and a really incredible way to reach a much, much more diverse audience. The last thing I'll show you, and then we'll get back to the slides and survey results, is PDF functionality. So in addition to video, cognitive services can also go after many other different document types, in this case, PDF. So many of our documents we have in our corpus are PDFs, business documents and oral histories and other things of that nature. So I'll pick one just for argument's sake. Let's pick, it doesn't really matter. I'll just pick this one, Xerox Research Centers. Oops, hang on. Demo. Let me go back here. And we'll pick this one. And I don't know what's happening. So with that, we'll go back to the slides. I have no idea what this is. Always happens in demos, but you get the gist of it. Basically, we can give it other different document types, PDFs, Word documents, what have you. We can also do transcription, we can do translation, we can search for people, we can search for places, we can search for images. So the same kind of functionality exists in any sort of document type, whether it's an audio file, whether it's a video, whether it's an image, that type of thing. So you should get a rough idea of what we've done with the prototype and the power of the technology. So with that, let me go back to the slides. And what I'd like to do now is turn it back to Paula to talk about some of the learnings and experience that we had with some of the survey results and some of the feedback we received from the participants.
Hello again. Thanks, Dave. I think it's really, when you start dealing with machine learning and people get outside their usual comfort zone or their training and what they're used to at work, communication is really critical. And everybody was enthusiastic about this project. I don't want to say anyone, and they're really enthusiastic about continuing it in the collections and exhibits department, but we really need to be able to work cross-functionally. And I think that's one of the major things, even though this is a relatively small grant, it's really important to think about, do you have a common language with IT? And here, when we say business, that's the collections department. And does the developer understand what we're talking about? Because they might not have worked in a project for a cultural institution, and our aims might be a little different than for another type of organization. So, but I think as long as, so I think that's really important also, because this will be, I think, our greatest learning going forward as we expand upon that, is that communication and understanding and using the same language, or at least understanding there's other terms for things. And don't overscope it is really important. I think as a cultural institution, we're always thinking about resources, and we have this opportunity, and it's like, let's throw more things into the website and see what it does, so we can help figure out how to go further. But the more you throw into it, the more time you spend. And there was actually one road we went down that we had to scuttle in the end. So it's really important to think about what the scope is and what you can do. And that's partly of being flexible too, going down the list. We did end up scuttling one aspect that in the future we do definitely want to bring back, but based on what we had used as our starting material, it didn't work. And what really became clear, I don't know if people noticed in the demo, but we do have some keywords, and we have already built made transcriptions for the oral history we used in the demo. And we really wanted to use that because we could do a compare and contrast. But it really became clear that using only machine learning was not enough. We need to really have provenance data in there so folks understand where stuff came from. We needed to really think about what was the most critical terms for the human, and that really became human-generated metadata in some instances to understand. One of the false hits we got quite a bit within photographs, not in the example that Dave showed, was kitchen appliance kept coming up as one of the tags because some of the mini computers looked like a small refrigerator. And so it's really helpful to be able to compare and contrast the human-generated metadata, even if it's limited, with the metadata that the machine also came up with. But, and by far, I'm going to keep saying this, the translation and the transcriptions were really amazing from a collections point of view, where everything seems to always be backlogged. And I know you'd still have to pay for digitizing your moving images, but the idea that you could pinpoint do a search on a transcript and find it and then use that snippet for your own content or for a documentary or just for a researcher is really amazing to open up the black box of most institutions' video archives. And that's also part of the translation, again, is really important because it just opens your collection to a worldwide audience that we really have never been able to do before. And I think, especially as the Computer History Museum, that's really important. Going forward, the idea of training would really help. Again, getting back to my kitchen appliance. But in general, we were really happy with the results. Next slide. Thank you, Dave. So this sort of just gives you, we did do a survey. We were really curious what people thought. And I think the main takeaway that I get from this slide is that internally we were more critical of the results than externally. So internally, we know our collection. We always want to get through the backlog and make more things accessible, but we know how to do that. It's just the lack of time. Externally, whether it was other cultural professionals or it was researchers, because we asked a number of researchers too, was anything is better than nothing, to simplify it, and they just loved having access to it. So next slide. So the usefulness of the metadata. I think again, you'll see differences in internally and external, but even though there was definitely some false hits, the keywords were really important. It really just made sense that we had extra ways of searching. Topics essentially translates to themes. They provided definitely some use, and as Dave illustrated, people were really interesting, and you could really gain a lot from looking at people and trying to identify them. So that was really useful. And I think going forward, all will be useful, but additionally, people, we have this idea of linking the people to Wikidata. So if we can create structured linked metadata, so we can say that these are the birth and death dates of these people, these are alternative names or nicknames for these people, I think it could be so much more useful. I have to say that faces and sentiments, maybe in other videos, they'd be more useful than the oral histories, where it's pretty much somebody sitting and talking the entire time. But I think for our purposes, I would leave that to companies who want more marketing material and understand how people react to marketing. But it was very interesting to experiment with that. Next slide. So again, I am just amazed at how the transcription opens up our video collection. And it will do that also as we digitize more. The next phase, we're going to digitize a lot more archival material. And I think it will really open that up as well. So I know I keep saying this, but I just love the transcription. I've been in the business many years, and I'm just wowed by the potential of transcription followed by the translation. Next, and I think it'll open up new areas of scholarship that we hadn't thought about before. I think that's really important too, that having all these things at your fingertips, especially the time codes, and even if it's not the most perfect transcription, you can just do and better search functionality. You'll just make all kinds of different connections and ways of using your collection, whether it's internally or externally. For the quality of machine learning, I was actually surprised at the quality. Maybe you can call me a skeptic, but and I know things are even improving as I speak, but everybody was really impressed with the quality, that it was useful. It wasn't just there. It was really, really useful. And I think if we did more training, as we talked about, of the algorithms, and we added human metadata, human-generated metadata on top of it, and the Wikidata, it's just something that can't be beat in a way for opening up your collection. So, and the respondents, as you can see on the slide, were actually thought it was really good too. They weren't upset about what they were searching for. I think the one issue I'm a little concerned about with quality, and this might be okay as we move forward, is you don't want to get proper names wrong. A lot of people search by proper names. They might not know a nickname, or especially depending on where they come from and what their names are and how the machine learning algorithm was built. You don't want to mess up people's names, both for search purposes or it doesn't look good. But I think a lot of that can be solved by some of the issues we're talking about. Next slide. So, and I'm going to turn this over to Dave.
All right. Thank you, Paula. And as you can see, I mean, really great feedback on the survey results and overall very promising. And as I said at the onset, this is not going to replace a human in the near term for some aspects of it, but will absolutely augment the utility and the ability to search our collection. And certainly the language capabilities are really powerful, and being able to translate from any language to any other language. I mean, we showed translation from English to a different language, but it goes in any direction. It can be any language to any other language. So the ability to reach a much broader audience is very, very powerful. And it doesn't have to be video. It can be documents, it can be anything. It can be your website. So powerful concepts. I want to just take a moment and talk about this project, this prototype, in terms of a broader initiative at CHM. CHM has an initiative underway we call OpenCHM. I touched on this briefly, but let me elaborate slightly. OpenCHM is both a philosophy and a technology framework to open up the museum. And when we say open up the museum, the collection is, of course, the first and best customer for that initiative, but it's really a broader initiative to develop a suite of APIs and tools so that others can come to the museum, both virtually and physically, and mine our content, mine our collection, and help us tell the stories that we want to tell. We have an amazing team within CHM that can tell amazing stories, but we also believe that there are other folks out there that can also tell great stories, that can make connections that perhaps we can't make. And over time, our APIs will allow us to tie into other institutions and other sources of data. So Paul had mentioned Wikidata, but it could be Wikidata, but it could also be other institutions, other collections. So we think that's a really powerful notion. And you can imagine that if over time, more industries in the cultural space or the GLAM space, the galleries, libraries, archives, and museums space had open APIs, and this space is just beginning sort of this journey. If every organization in the GLAM space had open APIs, we could build some really powerful set of capabilities, these federated experiences where guests now can experience content from multiple organizations at the same time and build connections from a global perspective, we think is a really powerful notion. So that's what we call OpenCHM. And you can see in the timeline where we are, we're early on this journey, but we have a great vision and great commitment and great partners that you saw. But we began with some work with the IMLS prototype, again, to test the efficacy of machine learning against a subset of our collection, and some really promising capabilities with machine learning. So we're going to continue that journey and continue to keep an eye on it. There's also some really interesting things emerging in the machine learning space, which we didn't touch on. And that's in the space of things like deep fakes and other things like that. So the ability over time to bring people back to life, to tell other stories with synthetic people or avatars or what have you. I mean, it's a really interesting space and sort of unprecedented. So we're all collectively on this journey together. So in addition to sort of the broader OpenCHM, we're retrofitting our DAMS and CMS. So the DAMS is the digital asset management system, and that sort of holds the digital assets, the video, the media, the documents, that type of thing, the digital content. And then the CMS, which is the collections management system. So the CMS is about managing the metadata and the workflows and ingress and egress of content in the collection. And we're partnering with a company called Terentia. So shout out to Terentia for their partnership and the great collaboration and great tool set that they're providing to help us do that. And then, of course, we're improving our search capabilities, implementing things like Elasticsearch and providing more tools and more capabilities to make our collection available online so that others can connect to CHM, can use our collection and tell stories that perhaps we can't tell, or make those connections that we can't tell. So we're going to continue to watch and experiment with machine learning as it matures, and a really exciting space. And like Daniel, I've been in this industry for about 40 years myself, and I'll tell you that machine learning or AI, whatever moniker you want to put around this whole space, it's a really interesting one. And so whether it's self-driving cars or face recognition or what have you, while there's some cautionary tales that we need to pay attention to in the AI space, the promise for it is really quite profound. So stay tuned, and a lot more to come from OpenCHM and the GLAM industry at large. So with that, would like to thank you for your time, and this is our contact information if you'd like to follow up on any questions. But I believe we have time, about 10 minutes or so, if there's any Q&A that would like to do. So let me pause and say thank you on behalf of Paul and myself, and then we can open up for any sort of Q&A.
Yes, thank you, Dave. We have a very engaged audience, and they pour out a lot of questions. So I'm gonna just ask the two of you a couple of questions that kind of pop up in the Q&A section. The first one, obviously, we're all aware of the conversation about AI and machine learning bias and difficulties in dealing with specific issue related to gender, race. And so I was wondering if you can articulate a little bit, because obviously we had conversation internally when we approached this grant. And so if you can touch a little bit on how we address this issue in the way in which we selected oral histories and et cetera.
Okay, I'll say a couple of things, and then I'll hand it over to Paula. There's no question that the issue of gender and what have you with machine learning is not perfect. I mean, you see stories in the media and the press about challenges, recognizing different genders or different ethnicities or what have you. So it's not where it needs to be. But I will say the space is improving. The visibility is there. Organizations that are developing machine learning technology are well aware of these issues. And the one thing that's important to understand about machine learning is it's only as good as the data set that you feed into it. I mean, the whole point of machine learning is that the machines learn from the data that we provide. So we have to get better. It's not a machine or a technology problem, in my opinion. It's a human problem first. We've got to address some of the humanity issues around gender bias and other challenges, because it's sort of the old garbage in, garbage out in the computer science sort of vernacular. The quality that comes out is only as good as the content that goes in. So we have work to do there as a society to do better there. But the algorithms are getting better. The organizations are aware of these issues. The technology is only getting better. I'm confident it is an issue that will be addressed and will be solved, but it will take time. Paul, I'm not sure if you have any comments you want to add.
I agree with you that it will get better, and it's definitely a problem. I'd also like to add that when we were choosing the oral history videos, we tried to provide as much diversity as we could with our collection, both men, and we also did some theme stuff, but we also different accents, different people of color, to really see how the machine learning would work on that. And clearly there was definitely some stumbles, but hopefully with some training and as the technology gets better, it will improve.
Thank you. Thank you, both of you. There was another interesting question, because touch a little bit on conversation where we are keep having internally about how to present metadata generated by cognitive services. And in particular, there was like an interesting question about, we keep saying that the technology is going to improve. And so one attendee was asking like how we were thinking to address the issue of like, we're going back to update the transcript generated by the machine learning, and more in general, like the issue of making user aware of metadata, when the metadata is human curator versus metadata generated by the machine. If you can expand a little bit on this issue of the metadata, human curator versus machine learning.
Paula, why don't you take that one?
Yes, I was going to, because I've been thinking a lot about this, because it's like, how do we display our collection? How do we make it findable? And since we're building this whole architecture, which is really cool, and we can think both from the back end, the collections management, and we're building the front end, the new search interface at the same time, we're really engineering that so you can have basically on-off switches, and you can decide that you only want to search for the human-generated metadata, or you want to search for both. I don't think we're going to have an on-off switch for just machine learning metadata, and also whether you want to search the transcription or not. So we're also looking at color coding results, or some way to signify that these results are human and these results are not. So hopefully that will be effective for people to understand that. And I really think that's critical, and I'm excited about just letting people at it and comparing and contrast the different results and getting feedback.
Another thing I'll add to what Paul is saying, because this is a really important topic, and it's going to become actually critically important in the coming years. When an organization uses machine learning, whether it's deep fakes or machine learning or translation, it's going to be very important to let the end user know what is human generated versus machine generated, and whether you do that in a visual way, like this little indicator on the results. An article came out just 2 days ago, and it showed machine generated faces versus human faces, and it turns out, I can't remember the percentage, maybe it's 20%. Humans tend to trust machine generated faces more than human faces, natural faces. So there's some inherent bias there. So when you, in the future, you're having a conversation with a completely artificial entity, or you see a photograph that is not real, or a deep fake, or you see content that is machine generated, there's an obligation to let the end user know that this is machine generated, to keep sort of everyone honest. I think that's going to be critically important. So we've gone through some of those discussions internally. As we create more in this space, we'll highlight on the web pages of content, this is machine, this is human, so the human can make a decision, the relevancy. But this is going to be an interesting problem in the coming years that is not unique to CHM. It's a general problem that the industry is going to have to tackle.
I would also add, because we're a research institution as well, not just exhibits, we really want to look at this in depth and maybe have some programming around that based on our own results and make that available. I mean, this webinar is the first in a series of things I think we'll have talking about how we incorporate this and lessons learned for not just us, but others.
Thank you. These are, one of the exciting things that came out from this grant was exactly kind of test the opportunity for small, mid-sized institution to take cognitive services out of the box and running against a selection of video to test like how difficult the process will be. And an interesting question that came into the Q&A was like, what will be the challenges in scaling this approach to our entire collection? Dave, you spent a lot of time in this presentation to kind of describe how we would like to move forward. And I was wondering if you can talk a little bit about possible challenges that you see in moving forward with this approach to our entire collection.
Yeah, I actually think that the barrier is very low. I mean, the beauty of sort of Microsoft Cognitive Services and other organizations is similar, is that being able to tap into all that power that machine learning offers is really an API call. So you can store your content wherever you want to store it. You pass it to cognitive services, to the Azure cloud through an API call, and you get the results back. So I think it's not going to be a huge challenge. I think the biggest challenge is for us is going to be, how do we get all of our content to the cloud? How do we organize it? How do we structure the metadata internally? That type of thing. But from a machine learning perspective, it's a pretty frictionless solution now. I mean, the old days was very complex, training models, that type of thing. But now it's an API call, a RESTful-based API call, and it's become very easy to do. So I think it's just a matter of taking what we've done, learning what works well, learning what needs improvement, and then just scaling it out. So the sky's the limit, I think.
Thank you. There was a couple of other questions about a technical aspect that maybe we can answer quickly before the end of this program. One was related to the example that Dave, you provided during the demo, and was about the connection between the interviewee and Gordon Bell, via the awards. But actually, the interviewee was not talking about the awards, and so was mostly kind of a connection done on, kind of on the background. And so I was wondering if we can talk a little bit about the challenges to how we're going to analyze this connection and how we would like to use this connection in the future.
Yeah. So as everyone knows, I mean, the way that the human brain works is a synaptic network. One node can make a connection to many other things in the brain. And machine learning or deep learning uses a similar metaphor where one connection or one bit of information can make a connection to many other things, and in turn can make connections to other things. And over many, many different layers, you can essentially get a result and sort of fine tune what the output is. but it is that many-to-many connection model that makes this powerful. That's why you can take something like a Gordon Bell and know that he's the founder of CHM, and he was the VP of Engineering at DEC, and he was, Medal of Technology recipient, because one to many sort of relationships. So I think it's that's really sort of the power. The challenge, I think, is not going to be the parsing of the data. I think the challenge is going to be around the visualization of the data. Once you get all this content that comes back, so imagine you've got 150 terabytes of stuff, videos and images and photos, moving images and PDFs and documents in your own corpus, but then also connected to other things out there. How do you visualize that? What does that knowledge graph look like? How do you mine it? How do you search it? How do you navigate it? I think that's going to be the challenge. And there's a number of visual metaphors to do that, mind map type of notions, that type of thing. But I think virtual environments will give us a way to sort of swim through this data in very powerful ways. So being able to see a knowledge graph in 2D is not the right model. You need to experience it in 3 dimensions. And that's where virtual reality, augmented reality, and machine learning, I believe anyway, becomes hand in hand or hand in glove, the ability to navigate in really powerful ways and to grab something and see what that is connected to. I think that's kind of the holy grail of navigating this massive amount of content. So long way of answering it, but the short answer is the visualization is going to be one of the bigger problems, because if we think we've got a lot of data now, just wait, there's a lot more data coming as we mine it with machine learning.
Thank you. We have 1 minute left, and I was wondering, we have a lot of question about kind of, again, like the question of how long the process was, and one thing that maybe we can end up in the Q&A is what was the main challenge that you were surprised to run into in running this grant?
I'll say a couple of things, then I'll have Paula sort of round it out. I think the main challenge is that we went into this without necessarily a deep understanding of the results we would get with machine learning vis-a-vis the collection. So once we do, that's why we do these prototypes. That's why you do the research. That's why you test. So once we get this data back, great. What do we do with it? How do we visualize it? That type of thing. So it was kind of learning said a different way. We didn't know what we didn't know is a better way to put it. So I think that was a really sort of good learning for us. And now we're much more educated and know a lot more and much more well-armed for the next phase of this. Anything you want to add, Paula?
I think communication is critical because there's so many moving parts. And I think we learned a lot about that. And I also think that we had, on the top of it, we had maybe, at least from the collections department, we thought we could solve more problems with it and do things. Even though I'm excited about the results, we did want to do a knowledge graph, and we had to get rid of that in the end because it wasn't working. So the visualization, I'm really excited about, but I think that's not quite here yet. And we really learned that we have to be careful how we scope, because I was very excited about a knowledge graph and seeing how our connections, the interplay of our connections that you don't normally expect to see is. And I think once we have more digitized, we will have some great tools for researchers and ourselves to dig into the collection.
All right. So with that, I'd like to thank everyone on behalf of Paul and myself. Stay tuned as we continue on this journey. We learned a lot. As we mentioned, it's just the beginning of a much larger journey that we're on, OpenCHM, and we'll continue to share our results and learnings and experiences as we progress. So thank you all for attending, and hopefully you found value in our discoveries today.
Thank you.